So many students have problems understanding how to calculate the sum of arithmetico-geometric series, and JEE has in the past asked many questions on it. In this video, I'll try to make you understand the general method by which we can go about calculating such series. Consider an AP given by A plus D, A plus 2D and so on, where A is the first term and D is the common difference. Let the arithmetico-geometric progression be A plus D into R. So R will be the common ratio and D is the common difference. So we have to find the sum of this. Now again, JE does not ask you this as a question like find the sum. It does not ask you directly. But there are many questions in which finding the sum of an arithmetico-geometric series is a subpart, and you need to understand how to do that in general. So let this be the series of whose sum we have to find. So let us call this Sn, and it is A plus D into r a plus 2d into r square and so on till a plus n minus 1d into r raised to power n minus 1. So remember, you have to just understand the general method, because you will not be, because I don't think by hearting the formula will help you in any way, because first of all the formula is very long and it's very easy to forget that. But if you understand how we calculate it, then you can replicate it anytime even if you have forgotten the formula. So the general way is to multiply the sum by the common ratio r and subtract the sum. So we have multiplied this by r and write the first, take the terms here, shift the terms one one by one, shift it one place to the right. So when you will do this, this term will become ar, write it below the second term. This term will become a plus d into r, write it below the third term. This term will become a plus n, the nth term. Okay, remember the numbering now. This is the nth term. So this will move furthest to the right. So this will remain alone. Okay, and the n minus 1th term, which is a plus n minus 2d into r raised to the power n minus 1. This will move here. So remember what we did? We multiplied it by r and then shifted the terms one to the right. We have just shifted it, right? But the beauty is, once you subtract these, once you do s minus r times s minus n, so this term will directly come here. But see, ar, we have subtracting this, they will get cancelled. You will get dr. Similarly, ar square, ar square, they will get cancelled. You will get 2dr square, dr square. If you subtract them, you will get dr square. Similarly, you will get dr cube. And from this term, when you subtract this term will directly come here right straight away. We're not subtracting it from any term. But this last term, the second last term, when you subtract it from when you subtract this term from the second last term, you will get d into r raised to the power n minus 1. So the subtraction becomes very symmetrical and you get this term as it is, the first and last terms as it is. But remember, this side you have a minus side because you have subtracted them and there is nothing here. So basically you are subtracting it from 0, the last term. So this will be minus sign, this will be the same, and this will beautifully form a geometric progression whose first term is dr and the common ratio is r. So this is all you have to remember whenever you are calculating it in the exam, because as I said, you will not, it's very tough to remember the formula, and I guess it's pointless to remember the formula, because this method will be applied in many questions, even in questions which are not AGP. Somewhere or the other this step will be required, multiplying by r and shifting the terms before subtracting them. So this is a geometric progression whose sum you know. But again, see, this is where many students get confused. So first of all, understand how many terms there are in this one. You have n minus 1 terms, okay? But the first term here is not 1, it is dr. So you can get confused as to the exponent with which you have to raise, because remember the formula for the sum of a GP is a times r raised to the power n minus 1 upon r minus 1. But here a, when you do this, the series is ar square and so on. When the series is this is the formula, but here the first term already has a factor of r. So be very careful when you find the sum of this series. If you do that, so my suggestion would be to take dr out, and it will then you will get 1 plus r square, so n raised to the power r raised to the power n minus 2. So when you apply, then you can get it easily. Then there is lesser chances of mistakes when calculating the exponent. But in any case, apply your brain and you will be able to find that finally the answer you will get for the sum of this GP would be dr into 1 minus r raised to the power n minus 1 upon 1 minus r. I told you all of this just so that you do not make a mistake while calculating the sum of this GP and especially this exponent, because the number of terms here and the common ratio, this is different from the standard formula that we use. Just keep that in mind whenever you're doing any question of sequence and series, because lot many times people mistake which exponent to use and then the whole answer gets here and there. So anyway, the final answer once, so just also keep in mind what is happening on the LHS. The left hand side is Sn minus r is rsn, so 1 minus r gets common, you move it this side, so which, so a becomes a upon 1 minus r dr. Here instead of 1 minus r you get 1 minus r square, and finally 1 minus r here. So this is the formula for calculating the sum of n terms of an arithmetico-geometric progression. Again, I am reminding you, do not have to remember this formula, but just remember how we arrived at it, which is multiplying the entire sum by the common ratio r and then shifting the terms one step to the right and then subtracting it. Now, in the special case where the mod of r is less than 1 and greater than 0, basically when you have an infinite AGP, similar to how you have an infinite GP, similarly when you have an infinite AGP, so we have already calculated the sum here, just substitute limit n tends to infinity. And remember the mod of r is between 0 and 1. So what you get s is limit n tends to infinity, this whole term. Now, this will remain as it is when n tends to infinity, because mod of r is between 0 and 1. This will tend to 0, this term, this will tend to 0. Similarly, this term will tend to 0. So first of all, you can completely ignore this term, and then here also you can ignore this part. So finally, the sum of an infinite AGP will be a into 1 minus r plus dr upon 1 minus r raised to the power whole square. If you can remember this formula, I would advise you to remember it, because in JEE mains, I have observed calculations can get very quick if you remember this formula, because this is a very simple series when you view it from an angle of JEE mains. The difficulty of this series is basically when you have it till n terms, and that too it will never be asked directly, that at least JEE Advanced will never directly ask you, okay, calculate the sum. The sum would be a sub part of a bigger question. Maybe it can come as a sub part of a question of complex number, or maybe a sub part of a question of permutation and combination. So there you need to remember the method that we have discussed here. So let us take a question of JEE mains, that what is this, 24th January second shift. Okay, so you have 7 is equal to 5 plus 1 by 7, 5 plus alpha plus 1 by 7 square, 5 plus 2 alpha, up so on to infinity. You have to calculate this value alpha. You are already given the sum. As I said, this is a question of JEE mains, that is why they have directly given it to infinity, because till infinity it is easier to calculate. You can either remember this formula and apply it here, because now you are already given the sum. D is what you have to find out. So you can either substitute the values here, or in general, what I've observed is in the pressure of examinations, children generally will not be able to recall this formula, or even if they are recalling it, you can make a mistake here and there. Again, go back to the general method, we discussed it here, write the complete series, multiply it by the r. R here is 1 by 7, so 7 into 1 by 7. Shift the terms one term to the right. 5 becomes 5 by 7, 5 plus alpha into 1 by 7 becomes 5 plus alpha divided by 7 square, similarly by 7 cube, and so on. So when you subtract this, you get 7 minus 1, 6, 5 directly comes here. 5 by 7 cancels out, you get alpha by 7. 5 by 7 square, 5 by 7 square cancels out, you get alpha by 7 square, because here it is 2 alpha, it is alpha, so alpha remains again, similarly alpha remains. Finally, you get, when I subtract 6 by 5, you get 1 here, and this is the infinite GP you get here, which is very simple. A alpha times a is 1 by 7, r is also 1 by 7, so a upon 1 minus r, that is the sum of an infinite GP, right? So basically you simplify it, you get alpha by 1 into 1 by 6 is equal to 1. Alpha, the value of alpha is 6. So this is a question of JEE mains. Simple. So yeah, The purpose of this video is for you to remember the general method of how to calculate the sum of an AGP, whether it be a finite AGP or an infinite AGP. The method is the same. Remember it. Subscribe to the channel for more such specific videos where we add value to whatever theories you might have already been studied in your classes. We add it keeping in mind the questions that are asked in JEE Advanced or JEE Mains. Basically, my focus is more on JEE Advanced, but in any case, follow it because whatever you will learn, you will be able to apply it in JEE Mains also. Watch my other videos because there again I have analyzed questions from a point of view of how, when considering the exam pressure, and not just when you are solving it at home at peace and when you know which part of the syllabus this question is from, when you already are aware that this question is from series, sequence and series, and so or theory of equations or complex numbers, so you know which specific part this is from. But in exam situations you generally are like confused a lot and under a lot of stress, so then how to approach questions, we focus on that in this channel. So please subscribe to it, watch my other videos. Thank you.